In this question, at 300 Kelvin, 36 gram of glucose present in a liter of its solution has a osmotic pressure of 4.98 bar. If the osmotic pressure of the solution is 1.52 bars at the same temperature, what would be its concentration? So according to the question, it is given that mass of glucose is equal to 36 gram, volume of the solution is equal to 1 liter, and osmotic pressure is equal to 4.98 bar. Here we represent osmotic pressure as pi. So now what happened? There is a certain change in the osmotic pressure. So new osmotic pressure is represented as pi dash. It is equal to 1.52 bar. So we have to find what is the new concentration of the solution. So the temperature is taken as 300 Kelvin. There is no change in the temperature. Only the osmotic pressure is changing, and because of that, concentration of the solution will change. So to solve this problem, we can use the osmotic pressure formula. So osmotic pressure formula, if we use, we can write it as pi is equal to CRT. So if we use our first relation, so here pi is equal to 4.98 bar. C we have to calculate. R is a gas constant and temperature is 300 Kelvin. So first we find the value of C. C is the concentration. So concentration for the first condition is equal to molarity, and we know that molarity is equal to mole of solute. So here the mole is glucose divided by volume of the solutions in liters. So first we find the mole of glucose. Mole of glucose is equal to mass of glucose divided by molar mass of glucose. So mass is already given here. Mass of the glucose is 36 gram. So we substitute it here. Mass of glucose as 36 gram. Molar mass of glucose is 180 gram, because glucose formula is C6H12O6, and if we found the molecular mass, so we have to 6 into 12 plus 12 into 1 plus 6 into 16. So it will come 180 gram per mole. So here we can cancel it. It goes by 5 times. So 1 by 5 is equal to 0.2 mole. Now we have the mole of glucose and we have to find the concentration. So concentration is equal to mole of glucose divided by volume of solution. Mole of glucose is 0.2, volume of solution is 1 liter is given, so 0.2 mole per liter is the concentration. So this is our first relation, and in this relation we already have concentration value known. Gas constant is constant for everywhere. So now let's use the second relation based on the second condition, where the pi is equal to, or pi dash is equal to 1.52 bar. So here we can say that pi dash is equal to C dash R into E. So if this is our relation second, so what we can do from relation first and second means, if you consider this relation, and here if we substitute the pi value as 1.52 is equal to C dash into R into 300 Kelvin. So we have to divide it. So we can write it as pi by pi dash is equal to C by C dash, because these R will get cancelled and the temperature is also gets cancelled because they are same. So pi value is 4.98 and pi dash is 1.52. C concentration, how much we got? It's equal to 0.2 mole per liter. So we can substitute it here, 0.2 mole per liter, and we have to find the value of C dash. So C dash is equal to 0.2 into 1.52 divided by 4.98. It's equal to 0.061 mole per liter. So we got the concentration or the new concentration when our osmotic pressure is 1.52 bar. So this is the answer of this question.